Hello again, Steve Case from Semantic Arts. Our next speaker, Jay from Intuit, is going to be really describing a lot of the journey itself that he took. He calls it weaving data-centric thinking into enterprise architecture. Very interesting subject as to their journey and their maturity along the way. Jay, take it away.
Hi, everybody. My name is Jay Yu. I'm an enterprise architect at Intuit. It's an honor and pleasure to speak here to share some of our learnings. I just want to actually make sure you understand this is not a deep technical discussion. It's more about strategy. It's more about the journey. But I hope you I have a few examples so you actually see how this strategy can turn into real use case and so on and so forth. So the agenda is the following. First, I want to talk about a little bit about Intuit. What do we do, who we are, what we are trying to do, what's the company strategy, and how that linked to the technology and data strategy. And then I'm going to actually share a little bit about the challenges we were facing when we started on that journey. Of course, the journey itself is the bulk part of the talk, and then I'm going to share some of the lessons we learned before I summarize. I hope most of people here has heard about Intuit, but I don't know whether you know we have a very big and bold mission. Our mission is powering the prosperity around the world. Today, we're known as a company with a number of flagship products. It's gonna actually it's touching many people's financial lives. Let's start with TurboTax. We have about 55 million taxpayers, filers using our software to get their taxes done. If you have not done using TurboTax, please try it. We also have a personal finance product called Mint, help you aggregate information from all financial institutes. You have a one single place, give you a 360 view of your finances. We most recently actually just acquired a Credit Karma, which has a huge customer base focused on provide free credit score, but also helping you make better decisions by offering all the personalized, relevant, loan, mortgage rates, auto loans, and so on and so forth. Anything you can think of, we can help you. On the other side, we also cover small business. We have over 5 million small business owners using our software to manage their accounting, manage their business, including payroll, payment. And then we're not doing it alone. We actually, as part of our ecosystem, we actually connect people with professionals. As you know, accounting or tax sometimes is challenging. We don't expect everybody can do it yourself using our software and service. So we actually supplement, augment our software with human expertise to help you address everything. So this is actually a big, we have a big mission. We have a bunch of products, but we're going through a huge transition. We realize in order to help people, in order to get really close to power prosperity of the world, we need to flip around, think about Intuit as an ecosystem instead of just a house of many products. And that ecosystem at the center place is what we really passionate about. Can we make sure we can power people's prosperity by giving people more money, finding opportunities every possible with minimum work. We want to automate as possible, but also provide complete confidence. So it's not completely black box. And this whole strategy actually requires us, we look at our technology architecture, basically requires us to look differently. We just say in order to realize this ecosystem vision, we have to embark on the journey to become an AI-driven expert platform. So what does that mean? So by AI, artificial intelligence, we focus on the three areas. One is on symbolic, which is knowledge engineering. As you know, in our space, compliance, rules, accounting, there's fair amount of rules there. How can we codify rules in a declarative way? I'm going to share an example how we do that, how we successfully apply semantic technology to do that. Of course, machine learning, deep learning is big areas. We want to get insight. We want to actually personalize our experience. And also we believe, visual-based interface is no longer the mainstream. Actually, we're going to move towards more natural language-based interface. So what does that mean? So that's the 3 areas we focus on. But as I mentioned, we need to combine those with expertise. We're not selling product and service, but also we're providing expertise. We have very deep domain expertise, domain knowledge in the areas we're covering. We also rely on human experts to provide the last mile or whatever the things necessary to make sure we can help you handle complicated financial situations. Guess what? In order to do that, we need data. We need clean data. We need data with rich semantics. We can no longer think about those data only locked in service of application. We have to think about data is the center, has to be application agnostic. So this is where, data-centric architecture is really the key. We didn't use the term. When I actually connect with Steve and Dave, we realized we're talking about the same thing, even though we use different terms. So for data, I'm not going through a lot of details. As you know, in order to clean data means a lot, has to be accurate, valid, fresh, complete, has to be connected, entity resolved, and has to be understandable, traceable, also with proper governance. Of course, needs to be discoverable, queryable, and then can, if add rich semantics, needs to be inferenceable and explainable. So this is where the gap exists. So while we have this huge company mission, we want to transform ourselves into an AI-driven expert platform. We know in order to do that, clean data and data with rich semantics is going to be the key. But what we had, currently or before, I guess there's no surprise. I think through this conference, we talk a lot about what's application-centric versus data-centric. So give you a simple example. By the way, for me, my learning is silos are actually is organic, is by nature. You cannot avoid them no matter what you want to do. The question is, what do you do with them? So a typical application, of course, needs to be driven by its experience. It has logic in the client tier, service tier, and data. And then we want to perform analytics. Guess what? We need to replicate data from the online store into a lake. We need to do an ETL, transform that to a data warehouse. That's for analytics. We need to build all kinds of pipelines to derive new data, to actually do feature engineering so that we can do machine learning. And then, of course, the output of that will feed back to the online system. So what's the challenge here? In this particular one, by the way, there's nothing wrong with that. If your company only building one application, this is the perfect architecture for that. But if you have multiple of that, then you realize data is often created and driven by individual UI applications. And it is by nature fit for purpose, optimized for those application features, because nobody wants to think ahead. Nobody wants to say, I get my data so clean, can be used by multiple applications. Or the first order of business is, can you get this thing out as fast as possible so our customer can benefit from this? It's very natural to think about, building up fit for purpose data. And then also, as you see from this picture, often the data needs to be replicated, cleaned up, because again, for application concern, it's different from analytics concern. They need a different view, different shape of the data, right? So anyhow, I had to go through this ETL process. The other area is more than just data. Data by itself only has limited. You have to put logic together with the data. Guess what? The traditional approach is all these logic are hard-coded, usually embedded in various systems, technology stack, distributed across. So that's actually what application-centric architecture is about. By the way, nothing's wrong with that if you're only building one app. So in our case, or in a very successful enterprise, you end up with multiple of those. So I just use 2 examples. Not only their applications different, their data is different. I use a simple example. Even the view about who's the customer, what's their name, you may have different representation in terms of schema. You may have different value or format, and so on and so forth, right? So that's the nature. And then by nature, they all moving as fast as possible using their own technology stack. Very likely is a legacy stack or still in their own silo way, try to refactor, get better. And then oftentimes you have to integrate data from third party. Guess what? By design, those are different silos. They don't represent the same data as we do. So you have to say, when you do the integration, you have to reconcile those data. But that's not it. You also have marketing, customer success. Within each silos, if that's all they do, which is fine. But oftentimes as a company, you do marketing, want to actually go across, customer success want to go across. And guess what? They have to aggregate data from multiple of those silos, and they have to create their own representation, right? And they very likely use their own technology stack, whether being third party or your own in-house. So this problem becomes worse and worse when the company grows, when you get bigger and bigger. And we realized immediately, back then, a few years ago, if we want to embark on this company mission, the AI-driven expert platform, this is a huge barrier. So what do we do about it? Actually, step number one is actually pretty straightforward. I don't even, it's really say you need clean data. Everybody's understand that, right? But what I want to share is even the clean data requires a little bit thinking. So what I'm sharing with you is the end-to-end data architecture at the very high level, at the template design pattern level, not a lot of detail. So when we look at the whole space, we say, yes, this is data coming from online systems, coming from third party. They themselves have their own stack. That's fine. We acknowledge that. It may take a long time to try to force everybody to align on a single model. I mean, it's always the desire, but execution is very hard. So why don't we do this? Why don't we create a set of foundational data capabilities? Can be common infrastructure patterns, technologies, stacks, can be used by all these teams to do what? Of course, some of the common concerns we have no choice have to do is data governance, metadata registry, data catalog, right? These are the things has to be taken care of. But then we just say, why don't we stream all the change events from the online system through this centralized pipe? And this pipe is going to cover a couple of things. Will be actually transform data to be much cleaner in terms of, can we standardize the data definition through this pipe? Can we standardize the format? Can we do matching, entity linking, entity resolution or through this stream? Can we enrich the data, augment data from other sources, external sources? The result of that, you can feed into multiple places. You can feed into a customer 360 store, including attributes and relationship. You can also feed into your typical data warehouse, analytics database, featureization for machine learning, reporting and analytics. But all these are in service to fit for purpose use cases. So in this case, I share a little bit example from a previous example of how data can be aggregated together. A different view about the same person can be reconciled, linked together, but with lineage and history also preserved. And then you actually provide that as a data platform, allow fit for purpose use case to operate on top, whether it be fraud detection, personalization, and so on and so forth. Again, it could be near real-time processing, it could be batching, doesn't matter, because you are all enjoy the same, you leverage the same high quality data there. And ultimately the goal is feedback to the online system to make sure the application, the user interaction is fully take advantage of all the great insights from the end-to-end system. So that's a pretty standard thing. I think the key thing here is how can we do it in near real time? So I don't have a lot of time to go through that. That's a different talk. So while we start with that, we also start thinking about, is that it? Is that only data? So, and some of us are very passionate about it. So while we're doing this journey, why can't we actually elevate data to knowledge? So what does that mean? There is a great model. I think you can look it up by Russell Ackoff. And usually it's called DIKW, but he put it in as DIKUW. Basically classify data as the following different levels. First, data is about symbol, is raw things, string values. The next layer is information. It's more like a structured data. You can answer the question about who, what, where, when. And then the layer above, you can start addressing the how question. So it's need a little bit more context, a little bit more meaning. And then the next level is why. That's actually really, really hard, much harder, right? That means you truly understand the patterns, the semantics, and finally you elevate to wisdom. If you have wisdom, you can solve for many, many problems. Again, I love this model. And what I call it is what's the difference between data or raw data to all the way to knowledge. So that process is something reflect into our journey. That's all what we're executing. First layer, you just say, hey, there's a lot of things we can have silo messy data, combine them together, clean them together, create this data graph. Let's call it data graph. We have not put a lot of semantics in there yet, but we put into structured and then we know how they relate to each other. Then the next layer is can we enrich, can we abstract? This is where we can start adding a little bit more semantics. But that's still not done yet. We can add inference and reasoning to it. That becomes a true knowledge graph. Now, how to get to wisdom? Maybe via query, maybe insight. We don't know that yet, but anyhow, if we can get to knowledge graph plus plus, that'll be a happy place. So what do we do? Now we have this great end-to-end architecture centers around data. But even you may argue without rich semantics, that architecture early on I shared still have a lot of value. But we believe there's much more value by adding semantics. So we actually went through a process, identify what are the areas we already doing really great by adding semantics, what are areas remain to have opportunities. So this is actually how we actually craft a multi-pronged strategy to see how can we weave data centricity into the whole end-to-end architecture. So the first area we look at it turned out to be one of the things we've been practicing for a long time. As I mentioned, the compliance space is so complicated. IIS have, 80,000 page of document, right? How do we translate that into code? It turned out, again, there's a place for applied semantic technology to make it more extensible, more scalable, more flexible. And then the next area, as I think I already mentioned by a lot of people earlier in the conference, is metadata catalog, data catalog, understand where your data are, what they're for, how they link to each other, is itself has a rich area for semantic technology to play. And same as standardization. While you're coming up with a canonical data model, how much semantics you want to push to elevate to the next level? Do you want to apply ontology there directly? In entity resolution, another area, you need to have common meanings before you can actually resolve them. And then, of course, you have customer 360. That's a classic use of using, let's say, knowledge graph to figure out, connect all the dots together. And many use cases in the fit for purpose use case. So what do? We identify these opportunities. So our strategy is really saying, we can expand on proven success. As I mentioned, I'll have a use case to share later. Is there any way we can also figure out in any of the fit for purpose use case, there's actually already bottoms up, there's actually teams already realized, for example, in the fraud detection, relational database just won't work, right? Going to a graph database, doing deep link analysis, that's the only thing, and then doing it in a real-time fashion. So let's celebrate those early wins. And then also let's expand on those by having the area that's supposed to give, all the system into a holistic view of our customer. That's a very rich area. So we want to connect with the new use cases there. And then we keep exploring certain areas we may not be as ahead. We're using a lot of existing solution or tweaking existing solutions. Is there any opportunity to go there? So let me quickly go through one of the use case. I don't have a lot of time. So in the case of business logic, think about, knowledge graph can be used to model knowledge or itself, rules itself. So instead of writing procedural language programming statement like a Java or Python or C++, say, hey, this is the tax calculation logic. We actually model the whole text action logic as a calc knowledge graph. And it's pretty simple, right? Each node, there's actually calculation nodes, there's actually input nodes, and an output. And why don't you just link them together? The immediate benefit is it's a very declarative, it's very granular. You can incrementally compose the complicated logic, and you can visually see the dependency. And runtime, you can capture the data flow, and you can only calculate the one that's changed. The other parts you may not recalculate the whole return. And finally, we found one of the big benefit for this from a customer point of view, besides more accurate, more up-to-date, is really explainability. There's a feature in TurboTax. I highly recommend everybody try it out. By the way, you can start by free. In some case of the user experience, we give you this feature called Explain Why. If you click on it, we'll explain how we calculate your return. That explanation is automatically generated. It's based on this calc graph, but it combined with all natural language generation capability. So that's actually something with tangible benefit. We see that when we deploy to production, there's immediate benefit right away. So that's really, we want to expand our proven use case, use that as a way to illustrate how important it is to elevate data or rules to knowledge. The second use case is more about Customer 360. This is a relatively new platform we've been building in the last 1 or 2 years. And of course, you may have different approach to it, but I think the key thing is the team was able to identify a very concrete use case. How can we connect visitors to logged auth customer, right? That in that sense, you can build a complete end-to-end customer journey. It's much easier for you to recognize when customers show up in your front door, who they are, where they left off. It's much frictionless. We can simplify, automate some of the designing, and ultimately we can provide a lot of personalization. So when we actually latch on that use case, develop the solution for it, immediately we see some quick wins right away. So this actually tells us it's good always identify opportunity with real pinpoint. In this case, we have this disconnect. How do we connect them together? And the team actually went through a lengthy process using this to find out what is the most scalable technology is applicable, optimized for this use case, and then deploy to production to learn. And now they're in the process of expanding with more data attached to this Customer 360 can allow us to do more. The next one is in data modeling. In this case, we're exploring, to be honest. Still no conclusion yet, but we made some progress. We look at what are all the open ontology out there, like including Fireball, schema.org. We quickly conclude that a lot of those ontology themselves are fit for purpose, and sometimes the level of complexity does not warrant us to, adopt as is. So we're in the process that I try to do a homegrown but borrow, leverage ideas, concept, even some relationship from them. So I'm not going to share a lot there. So that's really overall thing. We're using some third-party tools to explore what does that mean to models, some of the entities concept in our space, to add semantics on top of the unified data model we're building. So the other things we realized when we embark on this journey, we have many teams, not many people, I have say like half a dozen teams embark on those use cases. We quickly realized we need to have a common set of core capabilities. So this is actually a high level of those capabilities in order to build knowledge graph at scale and empower many, many teams to be able to utilize this. We have to start with what is the right knowledge representation and reasoning. What's the right abstraction you need? So we call that a capability. It's a combination of expertise, process, as well as technology. As you see, there's other buckets about how do you acquire knowledge, how do you inject knowledge, how do you store and retrieve all of those based on vendor evaluation. How do you maintain knowledge? I think early on today talk about there's the time dimension. We believe there's a time dimension to the knowledge itself because our understanding of the world evolves. You cannot say upfront you can design the beautiful ontology will never change. And then as you see, no matter what, there will be fit for purpose knowledge graph, right? Initially designed to solving for certain things. How can we mesh them together? They'll cover the discovery exploration part. You have to be discoverable. People can easily explore. And finally, the reason you have knowledge graph is you want to do process on them. You want to run advanced graph algorithm, data mining algorithm on the graph directly. And finally, how can we actually add machine learning to combining that with knowledge graph? So it's a great area for hybrid AI, combining symbolic AI and machine learning together can actually yield much better result and much faster and so on and so forth. If you have that thinking, say these are a set of capabilities, then all the other use case becomes just vertical solutions on top. So that's what we want to think about it. And the way this is how that can be used to inform our technology strategy for knowledge graph, right? It's all those areas, how much we want to do, how mature they are, what technology is available. Again, this particular capabilities are technology agnostic. So it's easy, no matter how things evolve in the world, we always say this is the area we want to focus on. Hopefully, the expertise and the process and then the domain knowledge on this will not change. The physical implementation can evolve over time. So lastly, I just want to share a bunch of learning. I think I still have big time. That's good. So not too much. So very high level. I think when we go to the discussion, we can actually drill down a little bit deep. So first of all, what we learned early on in this whole journey is you have to be really clear about what's the unique add benefit. Because as you know, when you talk about specific use case, there will always be engineering team raise their hand say, I can solve this with the current set of technology, right? And the organization, large organizations usually gravitate toward much simpler approach, right? Safer approach to get the use case done. For them to take on something is almost like there's a completely different way to look at things. It's scary, it's challenging, it's also risky, right? So anyhow, and that means we have to upfront have to clearly talk about the unique value and benefit. So one of the example is in the fraud detection use case, the team went through to compare, different technologies with traditional technology and also knowledge graph-based technology, using data to clearly illustrate that's the only thing that's going to help to support our requirements. So by this, they demonstrate clear advantage over that. So value proposition. The second part is also in dear to my heart is how can we get people adopted? As you know, the semantic technology is not easy. For a lot of people is they have to have completely changed their mindset. Even from procedure to declarative, it's huge mindset change, right? And then we're talking about from relational to graph, from relational data model, traditional data model to ontology. It's huge change management. So we cannot underestimate how much effort it is. So the key thing is rely on the passionate group people already is there, start building upon that base, but also leverage whatever the momentum is happening. In this specific example, I will actually point out latch-on GraphQL is one of the great things happen to help the industry or to help this knowledge graph, because people suddenly realize, oh, these data served through API, they need to be connected. They're not siloed piece of data coming from this API and that API. I need to figure out how to orchestrate them, how to connect them. Can we just have a single endpoint? Can you just expose all the data behind those API via a connected graph? That's actually huge for people to start thinking about from a graph point of view, rather than just pure relational, or rather than the old way hierarchical, just give me a JSON object. So anyhow, that's actually, technology fit, as I said, right now it's still early in the industry. There's a lot of fragmentations, how we can actually focus on what we need. I will highly recommend doing benchmarking for you to understand what your use case need and then pick the right technology, but also jointly for all of us pushing for technology standardization. And finally, this is probably one of the most important things. Any big journey like this requires execution, agile execution. We used to have this slogan called big bold vision, bite-sized steps. And it's really important. And I'm going to conclude the talk with some of the key takeaway. You already got it. all AI-driven platform strategy is a data transformation strategy, but also it's about elevating data to knowledge. And finally, you need to make sure you cover these areas. And I would say, no matter what, you should start. This is the trend, and there's a lot of people here already share a lot of experience. We learn from each other. No matter how small, how big your project is, having the data-centric thinking is going to help a lot. And that's my talk. Thank you so much.